All right, I don't have 21 or 23 in front of me. So, all right, somebody read off 21 for me. Okay, and part of this was my fault. I didn't do one that had two of them like this on Friday, and I should have. All right, I did it in the other class, if it's any consolation. Okay. All right, so if you look at those, listen up. You see you have sine of theta twice, don't you? The idea is you can combine those together as long as the coefficient on theta is the same. Now, theta doesn't even have a coefficient, does it? Okay, so they're the same. So what I can do is actually combine those. Now, they're on different sides of the equal sign, so can I just switch some stuff around here? Okay, so what I'm thinking about is just take these two things and swap them. Okay, so I'm going to have, well, I mean, that's 4 times sine theta. Okay, but I'm going to be able to subtract it. Okay, so since this is right there, that's a positive 2, I would subtract it on both sides, and so you get minus 2 sine theta equals, and we're going to bring that 1 over, so it would be a positive 1. Okay, now this right here is exactly what you would think it would be. What would you think 4 sine theta minus 2 sine theta would be? 2 sine theta. And again, you can do that because the coefficient on the argument, which there really wasn't one, but it's the same. Okay, so what I'm saying here, if this would have been like 4 sine 2 theta, I couldn't have done that. Okay, and we're going to look at that today where we have those coefficients like that. Now, all right, what will we do from here? I can probably figure it out from here. All right, right, divide off the 2. Okay, and now we'll be able to solve it. So where is the sine equal to 1/2 pi over 6? Okay, yeah, and 5 pi over 6. Now, right, the direction said find all the answers. That's only 2 of them. So all of them will be plus 2 pi n. Okay, now, since I've done that, when you think, do we still need to do 23? Right. Mm-hmm. 11? Nuh-uh. That's where it's, I think, negative 1/2. Sure. 17? Okay. All right, so that one's really already isolated. Let me get a unit circle up so we can look at it. Okay, we're looking for where the tangent is 0. So remember how we get tangent? We do what? Sine over cosine. Okay, so right here at 0, this would be 0 over 1, which would be 0. Okay, so you've basically got 0 there. Right. And I'm gonna point that out in just a second. So x equal 0. Okay, does that make sense now? And like right here at pi over 2, if you did sine over cosine, it would be 1 over 0, and that's what you're saying. That would be undefined. Okay, so it's not at pi over 2. Right? Where else could it be 0? Right at pi. So if you did sine over cosine there, 0 over negative 1 is 0. Okay, so we got x equals 0 and x equals pi. Now, with tangent, we don't say plus 2 pi n, we just say plus pi n. Okay, and really, this one right here would, what's the word for it? We don't really need it. I mean, you could have, yeah, Because see, this one, thank you. This one would cover this one. Y'all see why? So you really wouldn't have to write this one. Now, if you write that one, that's okay. No big deal. All right. Okay, what else now? Yeah, in fact, yeah. That would be even better because 0 plus pi n would just be pi n. Okay. All right. Any other ones up through 23? Okay. All right. Now, let's go to these, and I know these are difficult. Yes. Uh-huh. Yeah, everybody's going to get the first answers right. Okay. And that's the good thing about it. Nobody's ever going to miss one of these questions all out. Okay, you're going to miss half of it at the most. Okay. Now, let's look at this. Let me bring my calculator up real quick. All right. So let's talk about how we get that easy first solution here. What do we do since we don't really know what that is on our unit circle? Yeah, inverse sine of that. So inverse sine of 0.8246. Okay, there's one of my answers. Now, I believe it said 4 decimal places, didn't it? So 0.9695. Was that right? 4 decimal places? Now, so nobody's going to miss that, or shouldn't. Okay, now it's the other solution. So here's the idea. We got to think about there's another solution out there that we have to figure out by drawing it. Okay, now let's think about it. Where is sine positive? All right, first quadrant and second. Okay, all all seniors take calculus, so first and second. Okay, now we've got the one in the first quadrant. Okay, because what pi over 2 is 1.57. Pi is about 3.14. Okay, so 0.96 something. It's going to be about right here. Now, we've got to find a solution, though, in the second quadrant, because that's where else sine is positive. Okay, so the solution over here is just, it's going to reflect over. Okay, but we got to figure out what's that angle measure. Okay, so what's going to help me find that? The reference angle. All right, question? Because sine is positive in the first and second quadrant. Okay, so we've got that answer. The first quadrant is going to come from the calculator. Second quadrant, we're going to figure it out. Okay, now somebody said that we're going to use the reference angle, right? Now, if I'm in the first quadrant, the reference angle is the same, isn't it? Okay, so I'm going to use my reference angle in red. So the reference angle in the second quadrant is going to be the same thing, 0.9695. Well, close. Right. And really not 3.14, but what is it really? Pi. All right, so y'all watch. They're kind of catching on there. So what we're looking for is this angle, right? Okay. Now, this much of it is 0.9 something. So how can we find the measure of that angle in standard position? Well, let's think about it this way. If I go all the way to the other side of the x-axis, that's pi, isn't it? Well, we want to stop right there, don't we? So it's just going to be pi minus that. All right, talk to me. Did that make sense? Okay. All right, so let's do pi. So I'm not really going to punch 3.14 because that's not accurate. The pi button, your calculator will take that out to 100 decimal places in memory. Okay. So minus and, right, answer, not that, but answer. All right, so our other angle here, our other answer, is this 2.17 2, 1. Okay, so it's really all about reference angles. Okay, you got to be able to use reference angles, and that's one thing that we rely on the unit circle. As I said way back, that the way I teach trig is a unit circle approach. Well, the only way you can do this is by reference angles. Okay, that's the only thing that you really have to have reference angles for. Now, let's look. You want to do number 87 too? Okay, all right. We'll do this one in number 89. All right, so let's do the easy part first. We're going to do inverse cosine of -2/5. Okay, so I'm assuming everybody's going to have this answer. 1.9823. Okay, now, so let's think about it. There's going to be two answers. Okay, where is cosine negative? Everything's positive in the first, second, and third. Look at your unit circle if you need to. Okay, should be second and third, right? Yeah, but we're looking for where cosine's negative. Okay, so third is going to be because everything's negative in the third, except for tangent. Yeah. And so cosine is negative in the second and third. Okay. Now, let's see which one that we've got so far. Remember, this is 1.57, 3.14. What's this one down here? 4.71. Okay. So where's that 1.9 something going to be? In the second. So I got the second quadrant answer. Okay. So I got this angle is 1.9823. All right. That from standard position. Okay. In a minute, we'll talk about the reference angle. Now, so again, where else is it going to be cosine negative? In the third. So I'm going to reflect it down here in the third quadrant. Now, that's what we don't know. Okay, that's what we got to figure out. So what we're going to need is the reference angle. Now, in just a minute ago, the first quadrant, it wasn't that bad because the reference angle is the same. But how are we going to find, remember the reference angles, the acute angle form of the x-axis? How are we going to find the reference angle here? Yeah, just pi minus that. Okay. Pi minus that. Okay. All right. Watch. We're looking for this angle right here, right? Now, if we go all the way around, that's just pi, right? Because, all right, listen. We're trying to find this reference angle because the reference angle down here is going to be the same. That's why we need it, okay? Is to figure out how far do we go down to get the reflection point, okay? It would just be the same, okay? But in the second quadrant, all you got to do is, well, what's the, this angular distance? All I have to do is take pi and subtract that from it, right? Does that make sense? What now? I get where you're going with that. I think you've got another way of doing it, and I think that actually works. We'll try it, okay? Now, so let's see. We said pi minus that, and so we got our reference angle there is 1.1593, okay? Now, so the reference angle, remember the reference angle is always acute, it's always positive because it's not done from standard position. So this angle down here is 1.1593. Now, that's just the reference angle. That's just this part. What we need is that angle in standard position. So that angle in standard position starts over here, goes all the way around. So to this point would just be pi, wouldn't it? So I need to do pi and that much more. Okay. Now, what you were saying would work pretty good. Yeah, because what you're doing is you're finding it in this direction. Okay, that'll work too. There's more than one way of doing it here. So I'm gonna take this, what I got in my calculator, and just add it to pi. Come on, pi. All right, so there's my other answer. All right. All right, Danielle, do what now? I don't really know another way of getting that. Yeah. We'll do number 89. Okay. All right, 90. I'm gonna try to see if you can go back and do it again or not. Okay. All right. Let's try 89. Another calculated problem. So let's get the easy answer. Okay. Inverse tangent of 3. All right. So we get x is about 1.2490. Okay. Now there's two solutions. Where is tangent negative? Oh, okay. So I messed that up. Let's back up. I think it just changes it to negative. Okay. All right. There we go. Now that's a real big issue right there, because the directions say that we've got to find answers in between 0 and 2 pi. And if it's a negative number, it's definitely not in between 0 and 2 pi. So what can I do with that then? Add pi, okay, because the period for tangent is pi. So let's add pi to that. Yeah, it is. Okay, so here we go. Now that's a good answer. So 1.8925. Okay, now where is tangent negative? Second and fourth. Okay, so we got one answer in the second, and then the answer in the fourth is just reflected across. Okay. Well, right here we're saying that the angle is negative, not the ratio. You get what I'm saying? See, one of them's the angle, one of them's the ratio. It's kind of confusing. Now, let's see. This one was, that's what, 1.57, 3.14, 4.71, 6.28. Okay. Now, so where's that 1.8 something going to be? Yeah, second. I'm just going to put 1.8 right there. Okay. Now, there's really a shortcut with tangent. You really don't have to find your reference angle. Okay. Y'all think about it. It's being reflected. When you reflect tangent, it goes exactly across from it because it flips across the origin, which is halfway around, isn't it? Okay. So why do I always draw my arrows backwards? I'm just like arrow dyslexic here. All right. It's halfway around it. So halfway around is just pi. So all I got to do is take 1.8 and add pi to it. So you really don't have to use a reference angle on that one. Okay, so there's my other answer. 5.0341. And it's these two, right? All right, because we can't use that one. This one right here, because it's negative. Okay. All right, now, y'all take a look at those, okay? And I hope you worked them out with me if you missed them. The hard part is drawing to get that second answer. I get that. Okay, these are pretty complicated. Now, go back and you try to do the 86, 88, and number 90 now. Okay, since we've done those three, and we can still go over those tomorrow if y'all want to. Okay, so let me know. Now, let's look at something that's not necessarily hard, but it's just not very enjoyable. Okay, so we're doing trig equations to the end of the year. Okay, but this is what we're going to look at here: coefficients on the argument. Okay, they don't make them necessarily more difficult. They just make them really tedious. Okay, because what happens when you throw an argument in here? Do y'all know what I mean by an argument? Like something in front right there, like tangent 2x or tangent 3x. Okay, a coefficient on the argument. You have a lot more solutions. Okay, which means you have to do a lot more work. It's not necessarily that much more difficult. All right, but these are my least favorite. My favorite ones come tomorrow. I like the ones more. Now, let's look at this one. Okay, so I'm going to do most of the even ones that come from your assignment, and you have the odd ones. Now, so it says cosine 2x equals square root of 2 over 2. Now, the directions don't say find all the solutions. It just says find them between 0 and 2 pi, I think. Now, when we see this is when we're going to do this. Okay. Yeah, no, it's just underlining. All right. Now, so here's what we're going to do. Now, sometimes when I have a problem, it's not a good strategy, but sometimes when you have a problem, the best solution is to avoid it. So let's avoid it for a little bit, and we'll come back to it, okay? So here's how we're going to avoid it. We're going to let 2x equal a, okay? Because if we do that, we won't have a coefficient, will we? But we're going to have to come back and fix it later, okay? So now, this would make it say what? The cosine of a equals square root of 2 over 2. Well, that's pretty easy then. Okay, so let's figure out. It's a pretty simple one. Where is cosine square root of 2 over 2? Pi over 4 and somewhere else. Let's see. A is equal to pi over 4. And 7 pi over 4. Okay. Now, all right, here's where we got to face the problem. It was not A, it was really 2x. And even though the directions say that you only have to find the answers between 0 and 2 pi, that you don't have to name all the answers, you still have to use the plus 2 pi n thing here, okay? So what I'm going to do here is I'm going to say plus 2 pi n, even though they only say to find the solutions between 0 and 2 pi. Okay, now, of course, if that was tangent, we would just say plus pi n. Okay, now, it's not really a, but what is a? 2x. Okay, so now we have to face our problem. We avoided it. Now we're going to be confronted with it. All right, and let me do this to kind of separate it. So 2x equals 7 pi over 4 plus 2 pi n. Go away, calculator. We don't need you anymore. All right. All right, so let's see. What do you guys think from here on both of them? How do we divide by 2? Okay, so now I'm going to divide by 2, and I'm going to show you a trick right there, okay? When you take a fraction, because most of the time our radians are fractions, aren't they? All right, to divide something by 2, all you got to do is take the denominator and multiply it by 2. Okay, and so pi over 4 divided by 2 is going to be pi over 8. Okay, it's pi over 8. Okay, now plus pi n. Okay, now same thing over here. Divide everything by 2. So we get x equals, now what's 7 pi over 4 divided by 2? Right. Yes? Okay. plus pi n. Okay. All right. Now, here's where I would like the solutions to say find all of them, because that would be all of them. All right. But they only want solutions in between 0 and 2 pi. What I've given is all the solutions. Okay. So here's where the tedious part comes in. So what you have to do is you have to let n equal 0, 1, 2, 3, and so forth, so you can find them all between 0 and 2 pi. Okay? Now, I like the 0 one. And by the way, I noticed I didn't say negative, because if n was negative, that would be negative, wouldn't it? And 0 to 2 pi has to be positive. Okay? So most of the time, it's just going to be like 0, 1, 2, and 3. So if n equals 0, that's pretty easy. What's this going to give me on my first one? Yeah, just pi over 8. Okay? Because it would wipe that out. All right, now what about this one? No, because we're letting n equal 0. Okay, and so our next one, we're going to let n equal 1. All right, so now this is going to give me 7 pi over 8. Okay, now that's if n is equal to 0. Now, if n equals 1, let's calculate this. Okay, so if n equals 1, and that would be pi over 8 plus pi, wouldn't it? Okay, now, in your calculator, if you wanted to do this, you could punch in 1/8 plus 1. Does that make sense? Okay, now, I don't need a calculator, probably because I'm a math teacher. But how could I do it without a calculator? How could you think of pi in terms of eighths there? Right, 8 pi over 8. Does that make sense? This would be the same thing as 1 pi. So pi over 8 and 8 pi over 8 would be what? 9 pi over 8. Okay, there's a third solution. Now, let's think about that. Does that fall in between 0 and 2 pi? Yeah. So like, for instance, 16 pi, think about that. 16 pi over 8 is getting you to 2 pi in it. And that's less than 16 pi over 8. Okay, so that one's still okay. So once we get over 2 pi, we get to stop. Thank God. Now, let's do the other one. Okay, we're doing n equals 1. So if n equals 1 right there, the next is going to be equal to 7 pi over 8 plus pi. Okay, and there again, I'll do the same strategy. How could I think of pi as something over 8? 8 pi over 8. Okay, so that's going to give me 15 pi over 8. Now there again, how could I go back to what it said? How could I just throw that in the calculator? 7/8 plus, yeah, or 1. Okay, you could say 8/8 and it would work. Okay. Now, all right, let's try n equals 2. Now, you see where I don't like these? Because it seems to go on forever. Now, look what happens here, though. If n equals 2, we get x equals pi over 8. Now, plug 2 in right there. So that would be plus 2 pi, right? Now, I'm not sure what that is, but is that going to fall in between 0 and 2 pi? No. If you take pi over 8 and go 2 pi more, that's going to be bigger than 2 pi, isn't it? Okay, so I can stop right there. All right, so look how many solutions I had, because I got to circle them all. 4. Okay, so we had 15 pi over 8, 9 pi over 8, pi over 8, 7 pi over 8. Lots of solutions. Okay, so with this, with the coefficient having an argument right there with that 2, that measly little 2 caused all that work at the end. Yes. No, because that's all the solutions. Okay, we only want the ones in between 0 and 2 pi. Okay, so this really tells me like here and here, that's all the solutions. Okay, we only want ones in between 0 and 2 pi. So again, what we have to do is we have to substitute for n 0, 1, 2, and so forth. Okay, now most of the time you end up substituting 0 and 1 and 2 gets too big. Okay, but not always. Let's get another one. Okay, let's do a tangent one. All right, so we got a 3 right there, right? So let's avoid it. Okay, let's let 3x equal a. So we'll get tangent of a equals square root of 3. Okay, now where is tangent square root of 3? Pi over 3? Yeah, okay. And where else is it? It's going to be in the third quadrant. Yeah, 4 pi over 3. Yeah. Now, if my equation was just this, that'd be it. But it's not. Okay. It's not a, it's what? 3x. And even though the answers don't say find the general solution, you still have to say plus, now not 2 pi k, but just pi k, or I'm saying k, we're n k, it doesn't matter. Okay, so I'm going to add this onto it. Now, all right, I avoided my problem right here. Now I got to face it. So what is really x? I mean, what is a really? 3x. Okay, so we'll get 3x equals pi over 3 plus pi n. Okay, and then 3x equals 4 pi over 3 plus pi n. Okay, y'all see how tedious this is getting now? All right, so let's see. Can I start putting in 0 and 1 and 2 for n? Now I've got to get rid of what, the 3? Okay. So let's see, this is going to give me x equals. Now what's pi over 3 over 3? Pi over 9. And then this is just going to be pi over 3 times n. Okay. Now, same thing over here. Divide by 3. So we'll get, what's that? 4 pi over 3 over 3. And 4 pi over 9. Okay. Plus, bless you, pi over 3 n. Okay. Now, can I let n start being 0, 1, 2? All right, I'll make you a deal. I'm going to do 0. Y'all tell me what the 1 is. Okay. You know how I am. N is 0. Okay. That's pretty easy. X is just going to be equal to pi over 9. Okay. If x is, or excuse me, if n is 0 over here, it's just going to be 4 pi over 9. Okay. Now, what if n is 1? Okay. Substitute 1 right there. Okay. So that'd be pi over 9 plus pi over 3. Now let's use a calculator. So what could I punch in my calculator? Not 1/9 plus 1/3 just to get it over and done, even though I could find like a common denominator. We'll be like all lazy and stuff. Use my calculator. All right, so you get 4/9. All right, so we get 4 pi over 9. Now, that's actually redundant, isn't it? Because that's what we got here, isn't it? So we found the same solution again. No big deal. Okay, now let's let n equal 1 up here. Okay, so now what could I punch in? 4/9 plus 1/3 is 7/9. Okay, so we get x equals 7 pi over 9. Okay, now let's see, we're still less than 2 pi, aren't we? So let's let n equals 2. All right, so if n equals 2, we'll get pi over 9 plus, now if that's 2, pi over 3 times 2 would be 2 pi over 3. All right, did y'all follow that okay? N is 2. Because when I multiply like pi over 3 times 2, it's like saying 2 over 1, right? So it's going to give me 2 pi over 3. Yeah, and so do you notice a pattern that this one gets you what that one was? For some reason in tangent, they do that. Okay. All right, so you punch in 1/9 plus 2/3, and it's 7/9, is that right? Okay, so you just get 7 pi over 9 again, which is a little bit redundant. Okay, now let's plug in 2 on our other one over here. Okay, so if that's 2, if n is 2, we get 4 pi over 9 plus 2 pi over 3. Okay, so 4/9 plus 2/3. All right, yeah, 10 pi over 9. Now, am I getting bigger than 2 pi yet? No. Okay, right. It would have to be 18 pi over 9 before it got bigger than 2. Okay, so do I still need to keep going? Yes, unfortunately. Now, let's notice a pattern. Right, this one, when n equals 3, this is just going to give me that solution right there. It's a pattern. So I'm going to skip this one right here because I know it's just going to give me 10 pi over 9. So let's go to this one and let n equals 3 there. So if n equals 3, what would pi over 3 times 3 be? Which is just pi, or 1 pi. Okay, so we get 4/9 plus pi, or 4 pi over 9 plus pi. Okay, now we can think of that as 4 pi over 9 plus 9 pi over 9, which would be 13 pi over 9. Okay, now, is that bigger than 2 pi? No, got to keep going. Now you see why I said this? Okay. All right, n equals 4 is going to be the last one, you think? Okay, let's see. Question? Go ahead. Yeah, because 3 pi over 9 is pi over 3. Yeah, because tangent, you just say plus pi n instead of 2 pi n. Okay. Now, so for n equals 4, do we need to work that first one? No, it's just going to give me that one again, isn't it? Okay, so we're going to skip it. Now, let's let n equals 4, and I think this is actually going to be the last one. So if n equals 4, that would be, yeah, 4 pi over 3. Okay, so 4 pi over 9 plus 4 pi over 3. So I'm going to say 4/9 plus 4/3. Okay, that's going to give me, y'all said 16 pi over 9? Okay. All right. Now, if we let n equal 5, that's going to be the same. That's going to be 16 pi over 9. Now, if n is equal to 5, let's see. That's going to be 5 pi over 3 then, right? Okay, so 4 pi over 9. Yeah, it is. All right, I just want everybody to see why it's too big, though. Okay, so 4/9 plus 5/3 is 19 pi over 9. Now, 19 pi over 9 is bigger than 2 pi. Do y'all understand why? Because what? 9 goes into 19 two times with and left over. Okay, so this one's too big. Now, when you get to one that's too big, thank God you get to stop. Now, thank you. All right, do we have any solutions here? Yeah, we got a bunch of them. All right, yeah, it was 5. Is that really how much it was? Let's see, we got what? 16 pi over 9, 13 pi over 9, right? 7 pi over 9, which that one was redundant. Okay, 10 pi over 9. So you had 7 pi, so I'm not going to worry about circling it again. Okay, and yeah, 4 pi over 9 and pi over 9. Yeah, so yeah, 1, 2, 3, 4, 5, 6 solutions. Blah. So I don't like this. Okay, so how do you feel about coefficients on your arguments now? Yeah, I don't like them either. Okay, all right, let's do this one. Okay, now. All right, let's avoid the problem at first. We're going to let a equal x over 2. So we get tangent of a. This one actually works out pretty good. Equals square root of 3 over 3. Now, help me out. Where's tangent? Square root of 3 over 3. Pi over 6 and 7 pi over 6. Y'all check me. Is that right? Tangent is square root of 3 over 3 pi over 6. And 7 pi over 6. Now, we're going to say plus 2 pi n or just pi n? Pi n, okay. Because it's tangent, right? All right. Now we have to face our problem. What was a? X over 2. Okay. So we get x over 2 equals pi over 6 plus pi n. Okay. Right. So this time, instead of like dividing by 2, we'll get to multiply by 2. All right. So we're going to get rid of this 2 so we can isolate x. All right. Let's multiply everything by 2. All right. So they'll cancel there. Now, what about here? 2 times pi over 6. So just cancel. 2 goes into 6 3 times. So we'll get pi over 3 plus 2 pi n. This one. Same thing here. 2 goes into 6 3 times. So we'll get pi over 3. Oh, okay. I'm sorry. All right. So that would be 7 pi over 3 then, right? Now, I'm seeing a problem already. Look at that. That's more than 2 pi, isn't it? Isn't 7 over 3 more than 2? Okay, so that's too big. So that's good news. I don't have to worry about that one. All right, right. Now, so let's see. All right, if n equals 0, then what's x? It's pi over 3. Okay, now, if n equals 1, pi over 3 plus 2 pi, I don't know what that is, but if I add something to 2 pi, it's going to be bigger than 2 pi, isn't it? All right, so I don't really have to worry about n equals 1, do I? Because it's going to be too big. Okay, so that one was actually nice. It only had one solution. Because if n equals 1, let's look at it, okay? So pi over 3 plus 2 pi. I don't know how much that is, but if I add something to 2 pi, it's going to be bigger than 2 pi, okay? So that one's going to be too big. So there's only one solution on that. All right, now let's look at this one with this kind of a complicated one. It's a 2/3. Okay, so let's avoid the problem first. Let's let a equal 2 theta over 3. So we'll get cosine a equals -1. All right, so I think that's a quadrantal angle, and that's probably only one angle there. Where is cosine -1 at pi? And that's it, isn't it? See, most of these, they have like two solutions at this point, don't they? But because -1 is a quadrantal angle, it's not like in a quadrant, it's on an axis. So I'm going to have one solution. Now, let's do, even though it doesn't say, we got to say general form, which would say plus what? All right. Okay. Now, what is A really? 2 theta over 3. Okay. Now, we got to get rid of that 2 theta over 3. Right. So let's get rid of that fraction part first, right? We don't like that fraction there. So let's multiply everything by 3, and that'll go away. So now I'll get 2 theta equals 3 pi plus 6 pi n. Okay, and then you said what now, Christina? All right, very good. All right, so we'll get theta equals 3 pi over 2 plus 3 pi n. Okay, now let's let n equal 0. So if n is 0, theta is just going to be 3 pi over 2. Now, I like this part. What happens when n is 1? It's going to be more than 2 pi. Okay. I don't know what 3 pi over 2 plus 3 pi would be, but it's going to be bigger than 2 pi, isn't it? Okay, if it's bigger than 3 pi, it's bigger than 2 pi. All right, so it's just this one now. Okay. All right, last one. Thank God. I hate these. I really do. Okay. I'm going to love these tomorrow, though. Now, let's look at it. All right, we've got a big problem right there, so we're really avoiding it. Yeah. Huh? Yeah, I agree. Now, should have these problems go down. All right, here we go. Let's let A equal that stuff right there. All right, so we get sine of A. I was going to say crap, but I just said stuff. I guess too late. I just said it. All right. All right. So where is sine square root of 2 over 2 at pi over 4? And help me out. I can't think of the other one. 3 pi over 4. Okay. All right. Now we got to do our general solution plus 2 pi n. And now we got to face our problems. We got to plug in for A. What are we going to plug in? Right. So 2x minus pi over 4 equals pi over 4 plus 2 pi n. Yes, that's what we're going to do. Okay. Did y'all hear what she said there? We're just going to add pi over 4 to both sides. And then what would come next? Divide the 2. Okay. So if I add this pi over 4, it works out real nice over here. That's going to be 2 pi over 4, which is pi over 2. Okay, then what? By 2. Okay, so we'll get, what's pi over 2 over 2? Pi over 4. It's kind of like we got back to where we started. Plus pi n. Okay, now in a minute we'll let n equal 0, 1, 2, and all that fun stuff. All right, now let's do it over here. So we're going to add pi over 4, both sides. So let's see, that's going to be 4 pi over 4, which is just, think about it. It's just pi. Okay. Because we did it over 2. We're going to do it over 2 now. Okay. That's what you were just thinking ahead of step. That's all it was. All right, divide by 2. So we get pi over 2 plus pi n. Okay. All right, I got 0. All right, so it's pi over 4 and pi over 2. Okay, now, if n equals 1, what's it going to be? Let's do 1/4 plus 1. 5 pi over 4. Okay. All right, and then pi over 2 plus 1 would be 3 pi over 2. All right, now I bet 2 is going to be too big. It is. Okay. All right, now look what happens if n is 2. If n is 2, this is going to say plus 2 pi. So I don't know what pi over 4 plus 2 pi is, but it's going to be bigger than 2 pi. That's it. So 4 solutions on this one. Whoa! Blah.